Welcome to Digital Learning, an initiative of Department of Collegiate Education, Karnataka. In this session, we will be learning some concepts in numerical analysis. This is for the students of 5th semester BSc Mathematics program under Mangalore University. In this video session, we will be learning iteration method. The main objective of this session is to learn the steps of iteration method to solve the algebraic and transcendental equations. At the end of the session, the student will be able to use the iteration method to solve the algebraic and transcendental equations. Let us learn iteration method. We'll see how to solve the problems. So before that, steps to do the problems. Consider the equation f of x equal to 0. Let x naught be an initial approximation to the root. The first approximation is given as x1 equal to phi of x naught. Second approximation is given by x2 equal to phi of x1. In general, the nth approximation is given by xn equal to phi of xn minus 1. The procedure is repeated till the root is found to the desired accuracy. We'll see some problems now. Using iteration method, find the root of the equation x cube plus x square minus 1 equal to 0 correct to 4 decimal places. Let us consider the function f as x cube plus x square minus 1. In order to find out the interval into which the root lies, we randomly put values for x. At x is equal to 0, we see that the function value is negative, and at x is equal to 1, the function value is positive. So this means the root will lie between 0 and 1. Consider this equation. We will rewrite it as x is equal to 1 by root of x plus 1 and call this as the function phi of x. Hence, phi of x is equal to x plus 1 the whole power minus half. We'll find out the first derivative and see its absolute value in the interval 0, 1. We observe that modulus of this value is less than 1 in open interval 0, 1, and hence it satisfies the condition, and hence we conclude that this iteration method can be applied for the given function f of x. So we proceed. We start with the initial approximation x naught. X naught is a value chosen between the points 0 and 1. So let us take x naught as 0.5. The successive approximations are given by x1 equal to phi of x naught, which is 0.81649. x2 we get the value as 0.74196. Similarly, x3 is 0.75767. x4 will be 0.75427. x5 is 0.75500. x6 is 0.75485. x7 is 0.75488. So since the two values are approximately same up to 4th decimal places, we can do one more step. We will find x8. We get 0.75487 and conclude here. We stop here and conclude that the required root is x is equal to 0.7549. We will see the next problem. Find the real root of the equation 2x minus log x equal to 7 correct to 4 decimal places using iteration method. Let us consider the given function as f of x. F of x is written as 2x minus log x minus 7. In order to find the root interval into which the root lie, we randomly substitute values for x. When we put x is equal to 0, 1, 2 and when we put it as 3, f of 3 is negative, f of 4 is positive. So, this means that the root lies between 3 and 4. Before we apply iteration method, we have to check whether the conditions are satisfied. So, in order to do that, we rewrite the given equation as x is equal to half into log x plus 7 and denote this function as phi of x. Then we find out the modulus value of phi dash. We first find the first derivative and then find out the value of this in the interval 3, 4 and we get that this is strictly less than 1. So this means the condition is satisfied and we are ready to apply the iteration method. Since the root lies between 3 and 4, we choose our initial approximation x0 as 3.5. We find out the successive approximations. x1 is equal to phi of x0 and we get the value as 3.77203. Similarly, x2 is 3.7883. x3 is 3.78922. x4 is 3.78927. x5 is 3.78927. You see that these two values coincide with each other and hence we stop here and conclude that the required root is x is equal to 3.7893. In this video session, we have learnt how to use iteration method to solve the given equation.